Welcome to MOVITRAC LTP-B Basic and Intermediate Training. This is Session 6. In this session, we move into a new topic, one that's going to actually take 2 sessions to cover, and that's a new way to control your MOVITRAC LTP-B. It's called Terminal Control Mode. Terminal Control Mode is more sophisticated than what we've been using so far. In our last few sessions, we've been controlling our MOVITRAC LTP-B from its front keypad using the up and down buttons, the start and stop buttons, and the display. You can definitely run your VFD very basically in this way, but if you want to do anything more sophisticated, Terminal Control Mode is really the way to go. Terminal Control Mode relies on switches and other external controls to manage the VFD. So let's go ahead and get into it and see how we can run our VFD in this way. First of all, a few big ideas. Terminal Control Mode, which some people call binary mode, uses digital, that is on and off signals to control the VFD. Now, on the MOVITRAC LTP-B, it is not strictly a binary control mode because analog signals, that is variable voltages, may also be involved in control. But it's mostly binary. Most of the operations are done with on-off switches. All your connections go to the front I/O connector on the MOVITRAC LTP-B and possibly the relay connector as well. Typical devices used to control the VFD in terminal control mode include switches. A potentiometer may also be used, and for output information, indicators such as the LEDs on this hand control box are possible. However, let me also mention something else. Although we typically think of PLCs controlling VFDs over a field bus, if you have a PLC with digital I/O or relay contacts, you can control your VFD in terminal control mode. It's less sophisticated certainly than field bus control, but it's also very simple, and any PLC programmer can easily implement terminal control mode in this way. So do be aware of that. That is a distinct possibility as well. But in many applications, just plain old switches work just fine. Now let's do a quick terminology reminder here. With industrial digital control systems, in other words, what's commonly called 24-volt logic, the following terms mean exactly the same thing. A high, a 1, a true, or an on is equivalent to approximately a 24-volt signal going into the device or coming out of it. And a low, or a 0, or false, or off is equivalent to a 0-volt signal, something close to ground potential. These two signals, 24 volts and 0 volts, tell the VFD what to do. I'll be using the term high and low most of the time, but I'll use on and off, 0 and 1, true and false as well. So be aware all these mean the same thing. So let's talk about getting connected. You do the majority of your connections right here on the MOVITRAC LTP-B I/O connector, which is right on the front. Or if you have one of the high IP rating units, it's inside. We're going to go over the different signals and talk about the requirements for making connections to them. Let's begin by talking about the power supplies available on this connector. There are 2 different power supplies, and I'm going to begin this with a note. The power connections are for supplying switches and potentiometers only. They are not intended to power other external devices. Now, these are the power connections right here. There's a 24-volt supply and there's a 10-volt supply. And the reason I say you can only use them for this purpose is because they don't have a whole lot of current available from them. The 24-volt supply can deliver 100 milliamps maximum, and the 10-volt supply a mere 10 milliamps maximum. So these are meant just to energize switches and potentiometers. If you need to control anything else, you'll need to supply your own power. Second note here. When you're connecting external signal sources to the digital inputs, you're going to need to make sure that external source's ground is at the same reference as the power supply in the MOVITRAC LTP-B. These are the 2 ground connections. They're both marked 0 volts on the diagram. So for example, if you connect a PLC up to the digital inputs or outputs, you'll need to connect the PLC's signal ground to one of these 0-volt terminals so everything's at the same reference. All right, moving on. There are 3 purely digital inputs available on the MOVITRAC LTP-B. They are called digital input 1, 2, and 3. I've alluded to digital input 1 a number of times in previous sessions because that is usually our enable signal for the VFD. Now these digital inputs follow 24-volt logic, so you can connect them up to any 24-volt logic compatible output device. 30 volts is the maximum voltage that can come into them. They interpret anything between 0 and 2 volts as a low, and anything between 8 and 30 volts as a high. Two of the signals are hybrid signals. Analog input 1, digital input 4. Analog input 2, digital input 5 can be either digital or analog inputs. Of course, they cannot be both at the same time. If you configure them as digital inputs, then they behave just like digital input 1, 2, and 3. But if you configure them as analog inputs, then they will expect a variable voltage or a variable current coming into them. Here are their electrical specifications when they're functioning as analog inputs. They can accept between 0 and 10 volts when operating in voltage mode, or 0 to 20 milliamps or 4 to 20 milliamps when operating in current mode. There are also two outputs. Now these two are hybrid signals. They can either be digital outputs or analog outputs, again, not both at the same time. So analog output 1, digital output 1, and analog output 2 and digital output 2 can supply information to external devices. When they are operating in digital mode, they follow standard 24-volt logic, but when they're operating in analog mode, they output a voltage between 0 and 10 volts. In either case, you should never draw more than 10 milliamps maximum from an output. All right, so those are the digital and analog inputs and outputs available on the MOVITRAC LTP-B I/O connector. Now for the activities we're going to be doing in this class, you should wire up your demo unit like this. Digital inputs 1, 2, and 3 should be connected to switches which go to the 24-volt supply. You should also connect up digital input 5 to a switch, so we're not going to operate it in analog mode. It will be a digital input. And analog input 1 should be connected to a potentiometer. Notice the potentiometer is connected across the 10-volt power supply with the wiper going to the analog input. The potentiometer should have a resistance between 1 and 10K. If you set up your demo unit in this way, you'll be able to do all the activities that we're going to be doing in this class. Now, my demo unit is a little different because I have a circuit board that used to be sold for demo units. I'm not sure it's available anymore, but mine is slightly different. It has two potentiometers. So it has a potentiometer connected to each analog input. However, I will not be using the second potentiometer in analog mode for any of the activities. So you don't have to have your unit set up in that way. You just need a potentiometer on analog input 1. Now, if for some reason you have two potentiometers, let me give you a little tip that works fine for classes and training purposes. You can always use a potentiometer like an on-off switch. When you turn it all the way down, it will be like a switch that's turned off, and when you turn it all the way up, it's like a switch that's turned on. So since my demo unit has two potentiometers, I will be using the second one like an on-off switch. So you'll see me turning it all the way down, all the way up, treating it like a switch. So don't let that throw you. But if at all possible, wire your demo unit up to have a switch connected to digital input 5. All right, moving on. We must not forget that we also have two relay contacts available, which can be used in terminal control mode as output devices. They're available on a second terminal strip right below the I/O connector. This is the relay connector here. Let me explain how the relays are connected to it. Relay 1 has two contacts in it. It has a normally closed contact, which is engaged when the relay isn't energized, and a normally open contact, which is closed only when the relay is energized. Relay number 2 has just a normally open contact, so the relays are not identical. Relay 1 has two contacts, Relay 2 has only one. Relay 2, by the way, can be dedicated to controlling a break, and we'll talk about that in another session. These are pretty small relays, so be very careful what you put into them. They can handle up to 250 volts AC maximum, but only 30 volts DC, and the amount of current you can pull through the contacts is just 5 amps. So if you need to control something that requires a higher voltage or more current, what you should do is connect the relay up to a larger relay and indirectly control it in that way. Now, to switch your VFD to terminal control mode, you need to go to parameter 1-12 in the basic parameters. You've seen this parameter before. It selects the control mode that the VFD is in. We've been operating it in mode 2, which is keypad bipolar mode. To change it to terminal control mode, put a 0 in there, and that will select terminal control mode. Now, once you've selected terminal control mode, you need to do something else before you can actually operate your VFD. You need to select a control mode variant. You may wonder, what is a control mode variant? Well, let's talk about that. Terminal control variants are digital and analog input assignments that control the VFD in different ways. Remember, you have 5 inputs on your VFD. Digital inputs 1, 2, and 3, and then analog input 1, digital input 4, analog input 2, digital input 5. A variant assigns different functions to these inputs. For example, enabling or disabling the VFD, selecting the direction the motor rotates, picking a preset speed, possibly using a potentiometer to control speed. There are 27 different variants, so these have many different combinations that assign different functions to those inputs. 26 of these are predefined, and 1 is totally customizable. We'll talk about the customizable one in our next session. We'll talk about the predefined ones right now. So how do you select a variant? Variants are selected by parameter 1-15, which is in the basic parameters. The default variant is 1, but you can see here the complete list. So values 1 through 26 select different variants. Variant 0 is the customized one, which we'll talk about next time. So you can see from this list what each input does. Now we're going to talk about how to interpret these in much greater detail in just a couple minutes. But before we do that, I need to talk about the fixed set points that you can set in the VFD. The MOVITRAC LTP-B supports 8 fixed speed set points. So in other words, you set these in parameters. These are fixed speeds, and you can select them by using the digital inputs. You can have up to 8 of these. So here are the 8 fixed set points. Parameter 2-01, 2, 3, and 4. You can change these, of course, to anything you like within the motor's legal speed range. And then parameters 2-05, 06, 07, and 08 contain the other 4 fixed speed set points. So different variants may select from these 8 set points. Some only access a small selection of them, some can access all 8. So let's start with a variant example just so you can understand how to interpret those available variants. We'll start with the default variant, which is number 1. Of course, the number in front of it indicates which variant it is. And then each input, digital input 1, digital input 2, digital input 3, and the 2 hybrid inputs will have a function listed below them indicating what they do. So let's look at this one. This is a very good and typical example. Digital input 1 is labeled stop run. What that means is if you put a 0 in there, the VFD will stop, and if you put a 1 in there, it will run. So if you have a switch connected to this, when the switch is off, the VFD will be disabled, and when you turn it on, it will be able to run. We've been using digital input 1 as an enable signal. Almost all the variants treat digital input 1 as a VFD enable disable signal. There are a few exceptions, but it mostly has this function. Digital input 2 is a direction control input in this variant. If you put a 0 into it, the VFD will turn clockwise or forward. If you put a 1 in there, it will turn counterclockwise or reverse. With digital input 3, if you put a 0 in there, it will use a potentiometer to control the speed, so you'll have a smooth speed control. But if you put a 1 in there, it will select one of 2 preset speeds. I'll tell you how you select between the 2 speeds in just a second, although you probably can guess. Analog input 1, digital input 4, in this case functions as an analog input. It expects to see a potentiometer, a variable voltage source connected here, and it uses that for speed control when you're in potentiometer mode. Analog input 2, digital input 5 is functioning as a digital input in this case. If you put a 0 into it and you're in preset speed mode, then you will get preset 1. If you put a 1 in there, you'll get preset 2. Let's look at a few combinations of inputs just so you can get the hang of this. If you turn digital input 1 off, it doesn't matter what the other 4 inputs are going to be set to, because you're going to always get a normal stop. You've basically disabled your VFD. If it's running, it will come to a stop. It will use the normal deceleration ramp in parameter 1-04 if you're in a ramped control mode. Now, if you turn digital input 1 on and digital inputs 2 and 3 are both off, your VFD will run clockwise with potentiometer control. So the off and digital input 2 selects the direction, sets it to clockwise. If you turn digital input 3 off, it will select potentiometer control mode. And then if you turn the potentiometer connected to analog input 1, you will have smooth speed control from 0 to maximum. So that is one way to run your VFD. If you turn digital input 1 on, digital input 2 on, and digital input 3 on, you will select counterclockwise rotation, and you will select the preset speeds, either 1 or 2. Now to choose between them, digital input 5 is turned either on or off. In this case, it's turned on, which means you'll run counterclockwise at preset speed number 2. So whatever value is in preset speed number 2, that's what your VFD will turn at. All right, so I'm hoping that's making sense. If not, you may want to play this slide over again. We'll look at a few more variants though, and by the time we're done, I think you're going to feel very confident that you can interpret all the different variants and know what they do. Now, an important note, if you want to have a ramped stop, you need to set parameter 1-05, which is the stop mode parameter, to 0. That selects ramp to stop. This will give you controlled stops where you have a predictable deceleration. If you don't have it set to 1, it will be in coast to stop. You will have the uncontrolled stops where you really can't know how long it's going to take to stop. All right, let's look at another variant example just to kind of cement these concepts. We'll look at the next one, variant number 2. Digital input 1 is the same. That's just the enable disable. Digital input 2 is the same. It's the direction control. But digital inputs 3, 4, and 5 are quite different. Now in this mode, these 3 inputs all function as digital inputs. They form a 3-bit binary number. The least significant bit of that number is digital input 3. The most significant bit is digital input 5. So together they form a number between 000 and 111. What these do is they select between the 8 available preset speeds. So you can select 8 fixed speeds using these 3 inputs. Now, just a little warning here and a reminder, you've probably already noticed this, but the binary numbers are read backwards. In other words, the least significant bits on the left, the most significance on the right. Normally, when you see binary numbers written, they're read the way that we handle ordinary numbers. They're read from right to left, not left to right. So don't let that throw you. Here are all the binary patterns. If you put a 000 in, that will give you preset speed number 1. If you put a 100 in, you'll get preset speed number 2, and on up to 111, which gives you preset speed number 8. So whatever speeds you put in those 8 fixed speed parameters, that's what you'll get when you put these binary inputs. So if you need a lot of different speeds, variant number 2 is a really good choice because it gives you access to all 8 presets. Let's look at a few examples here. Of course, if digital input 1 is off, then the VFD stops. It doesn't matter what the other bits are set to. It'll use the normal deceleration ramp in parameter 1-04. Now, if you put an on in digital input 1, the VFD can run. If you have an off in digital input 2, it will turn clockwise. And then if you put an off, off, off in digital inputs 3, 4, and 5, that will give you the binary pattern 000. That picks the first preset speed number 1. If you set digital input 1 on, digital input 2 on, you will get counterclockwise rotation. And if you send an on, off, off in digital inputs 3, 4, and 5, that's the binary pattern 100. That picks preset speed number 2. And if you put an on in digital input 1 and off in digital input 2, that will select clockwise rotation. If you put an on, on, on in digital inputs 3, 4, and 5. That's the binary pattern 1, 1, 1. That will give you preset speed number 8. Okay, pretty straightforward. If you're a control person, I'm sure this made perfect sense. If this is new to you, again, you might want to review it, and you might want to review binary numbers too. When you work with VFDs, you definitely have to be able to handle binary. All right, one final variant example, and then we're done with looking at these. We'll look at variant 4. Again, digital input 1 is that enable-disable signal. Digital input 2 is still a standard direction control. Digital input 3 selects between two choices. If you put a 0 into it, it will use potentiometer speed control. And if you put a 1 in there, it will use preset speed number 1. So you have a choice between variable speed with potentiometer and a fixed speed preset 1. Analog input 1 is in analog mode, obviously. It connects to the speed control potentiometer. And digital input 5, which is obviously in digital mode, selects between two stop ramps. So if it's set to 0, you'll get a normal stop using the standard deceleration ramp. And if it's set to a 1, it will use the fast ramp, and it will stop the VFD more rapidly if you've set that ramp to a faster speed. Let's look at a few examples here. If digital input 1 is off and digital input 5 is off, doesn't matter what the others are set to, you will get a normal stop. This picks a stop with the standard ramp parameter 1-04. On the other hand, if digital input 1 is off but digital input 5 is on, the VFD will stop using the fast stop. That's the ramp stored in parameter 2-25. You usually set that to a faster ramp than the normal one. If digital input 1 is on, digital input 2 is off, digital input 3 is off, you're going to run clockwise with potentiometer control. And if digital inputs 1, 2, and 3 are all on, you will run counterclockwise at preset speed number 1, whatever that's set to. Okay, well, I hope you're understanding variants and getting a good feel for them, so I think it's time to put all this into practice. It's time for a hands-on. Here's what I'd like you to do in this hands-on activity. I'd like you to change your VFD to terminal control mode and select variant number 8. I'd like you to set the first 4 preset speeds, presets 1, 2, 3, and 4, to 100, 250, 500, and 1000 RPM. Set the normal deceleration ramp to 4 seconds and set the fast deceleration ramp to 2 seconds. Also, just be sure that you're in ramp to stop mode. That goes without saying. Then work out the digital input switch settings that you're going to need to supply to run the drive in each direction at each preset speed. So you're going to have to test those 4 speeds, both clockwise and counterclockwise. Then run your drive. Confirm you can operate the drive at those 4 speeds in both directions. And finally, confirm that you can do both a normal stop and a fast stop. You've got a ramp of 4 seconds for normal stop. You've got a ramp of 2 seconds for fast stop. Confirm that that works. You can do this either directly from the keypad or you can use LT Shell. I recommend LT Shell, which is what I'll be using. All right, pause the video, do the hands-on. All right, well, I hope that went well and your VFD behaved as expected. Let's go ahead and demonstrate this. First of all, we're going to have to work out our digital input switch settings. So let's look at variant number 8 to figure out what we need to do. Digital input 1 is the usual enable-disable. Digital input 2 is the direction control. Digital inputs 3 and 4 function as a 2-bit binary number. So with 2 bits, you can select 4 presets. So by setting these binary patterns 00, 10, 01, and 11, you'll be able to select the 4 presets. And digital input 5, again, is a ramp select. So if you put in a 0, you get a normal stop. And if you put in a 1, you get a fast stop. So all 5 inputs are functioning in digital mode here. This table shows the patterns you'll need to control the VFD in the clockwise direction. So if digital input 1 is off and digital input 5 is off, you'll get a normal stop. If digital input 1 is off and digital input 5 is on, you'll get a fast stop. And then the remaining patterns pick the 4 preset speeds. So if digital input 1 is on, the VFD can run. If digital input 2 is off, you'll get clockwise. And then digital inputs 3 and 4 give you those binary patterns, off, on, and on. That will select your 4 preset speeds. Now to run counterclockwise, you just have to change one thing. Digital input 2 goes from off to on. Everything else is exactly the same. So these are the patterns that we need. All right, so let's dive into LT Shell, get our VFD configured, and then we'll test things out. As you can see, I've started up LT Shell, and the first thing we need to do, of course, is to scan in and get connected to our VFD. So I'll click the Scan Drive Network button. And as you can see, it found my VFD, no problem. It's loading its parameters. These, of course, will be the settings from last time. Nothing's changed, so we'll go from there. All right, we're now connected in. So we need to change to real-time edit mode so we can go in and change the parameters directly. I'm going to do all the group 1 parameters first. Now the first thing I need to do is change from keypad mode to terminal control mode. So I go to parameter 1-12, change it from 2 to 0, that's terminal mode. Then I need to set the variant to variant 8, that's parameter 1-15. I'll change it from the default of 1 to 8. That's the one we're going to use. I'll go ahead and change the deceleration ramp time next, since that's in group 1, parameter 1-04. Change that from 10 seconds to 4 seconds. I'm also going to confirm that parameter 1-05 is set to ramp to stop, so we use the ramps, and it is, so we're good there. That's all we have to do in group 1, so we'll change to group 2. This is where we set our preset speeds. Parameter 2-01, I'll change it to 100 RPM. The next one I'll change to 250, then 500 RPM, and finally 1000 RPM. The last 4 presets I'm going to leave alone. And then finally, we need to set the rapid stop ramp in parameter 2-25. We'll change it from 1 second to 2 seconds. And that is everything. That's all we have to do to configure our VFD. So we will disable real-time edit mode and then head off to test things out. Okay, well you can see my demo unit here. Let me just review what the switches do. If you look down at the bottom here, you see my little circuit board. The first 3 switches from the left side are digital inputs 1, 2, and 3. When they're in the up position, they're off. Of course, I have 2 potentiometers connected up to my analog inputs 1 and 2, which also are digital inputs 4 and 5. I will be using both of these not as analog devices, but as switches. Remember, if a potentiometer is turned all the way down, it's like an off switch, and if it's turned all the way up, it's like an on switch. So I will be using these purely digitally. They don't actually control the speed in an analog way. And just to review what each of these switches does, digital input 1 is the enable-disable, the run-stop switch. Digital input 2 is forward or reverse. Digital input 3 and 4 form a binary number of 2 bits. The least significant bit is on the left, so that's the switch. The potentiometer is the bit on the right, the most significant bit. And then finally, digital input 5, which is the second potentiometer, selects between the fast and the slow ramps. When it's off, we get the normal slow ramp. When it's on, we get the fast ramp. So what is going to happen, since digital inputs 3 and 4 are both off right now, as soon as I turn digital input 1 on, the VFD is going to start running, because that is my first set point, preset 1. Just a heads up here, I'm not showing the actual motor here. You can just look at the display on the VFD. That will tell you what speed we're running, and I do assure you the motor really is turning at those speeds. So we're going to enable the drive. I'm going to turn digital input 1 on, and as soon as that happens, we should take off at 100 RPM. Let's see if that happens. And there we go, we're at 100 RPM. By the way, if you've forgotten how to get the RPM display, remember if you press the navigate button repeatedly, it cycles through different choices, and this is the RPM display right here. Let's go the other direction. You can see that works just fine. Go back to clockwise. Now we'll go to the next set point. We'll turn digital input 3 on. That goes to 250 RPM. We'll check the reverse direction. That's fine. Now we're going to turn the switch off, and we're going to turn digital input 4 on by turning the potentiometer all the way up. As soon as we get up there, it should jump to 500 RPM. It does. We'll check the reverse direction again. That looks good. Go back clockwise. And now we'll check our final speed by turning digital input 3 on. That gives us 1,000 RPM. And we've confirmed as well that we can go in both directions. So we've tested all our speeds in both directions. The last thing we have to do is check the stop ramps. Now, just a reminder before we test the ramps, remember we've set the slow ramp, which is standard deceleration, to 4 seconds and the fast ramp to 2 seconds. Now remember, those are for 1500 RPM speed changes. Since we're only doing 1000 RPM speed change, they will actually not take that long. The slow ramp will take about 2.6 seconds and the fast ramp about 1.3. We'll time that just to see if it comes close. So we're going to trigger a stop by turning digital input 1 off. And you can see there's our relatively slow ramp. Turn it back on. And now we're going to engage the fast ramp. So we'll turn digital input 5 all the way up there. And we'll trigger it by turning digital input 1 off. And you can see that happen twice as fast, which is what it's supposed to do. So there we go. Everything works. All right, that is the end of session 6. I think you've gotten a good sense of terminal control mode and some of the things you can do with it. However, there is much more to talk about. In our next session, we will continue with terminal control mode. We'll look at several more variants and we'll talk about the customized variant. So, see you next time.